The following presentation was recorded live at the AAPT summer meeting on July 24th, 2017. This talk on academic integrity was presented by Dr. Jeremy Morton, CEO of Expert TA, as part of Expert TA's on-site commercial workshop.
We're going to talk a little bit about the motivation and necessity for focusing on academic integrity. It's not necessarily my favorite topic, but it is something that we do need to discuss. We're going to talk about the spectrum of students. We're going to talk about what Expert TA has been doing and the associated results with that. We're also going to talk about the coming challenges. We're going to take a tour of the Expert TA system. We're going to try to focus on the positive aspects of student learning, which is what we really care more about. And typically when we give a presentation like this, we would spend the whole hour looking at those features. Today it's going to be truncated. We're only going to have about 30 minutes in the middle, and so we're certainly not going to be able to show every system feature, which means that you may have some question about the system or how you might use it in your classroom. And if you find everything else that we talk about today interesting and compelling enough, then we'd be happy to answer those questions and we can get to those. But what we want to do is spend about 15 minutes at the front talking about the academic integrity issues and what we've been doing so far, about a 30-minute tour, and then close out with the real challenges of this changing landscape of academic integrity and what we're going to do with our new suite looking towards the future. As part of that closeout conversation, we're going to do a review of the relevant research about cheating and results from those studies, and then we're going to use that as a springboard to talk about planning ahead and as the motivation for the features that we put in place. Again, academic integrity is not necessarily my favorite topic. There's some sort of negativity to it. Painting students as cheaters is not exactly what we want to do. We want to be very careful about that. And I think that the research that we have reviewed shows that is not the case. All students should not be villainized, but there's a very small percentage of students who are really going to go to every length to cheat, and everyone else is flexible, and the structure of the class, the structure of the materials are something that can control the outcome of that student's decision. The internet has certainly changed things in many ways. One of those things is that it has made access to information, including the solutions to physics problems, at the tip of students' fingers. They can go and type in a Google search, and pretty much the entirety of world knowledge to all of us is available. And the fact that you have this device in your pocket and you can search for what year was the Battle of Hastings or whatever it is that you're worried about at the time, you don't view that as cheating. You view that as utilizing a resource that you have here to gain access to information. And it really has changed student attitudes towards whether or not looking up an answer online is indeed cheating. In fact, there's quite a bit of research that suggests that student perspectives have changed. The bottom line, though, is that I think we would all agree, this is not a controversial statement, that students cannot master the topic. They are not going to learn how to solve physics problems unless they do the work themselves. If they go online and they get an answer and they type it in to any homework system, or they do their written homework that way, they are not going to really understand how to work that problem, and that's going to be reflected when they show up to the exam. And this is our responsibility as educators, to keep students from self-destructing in this way. It doesn't matter if they don't understand that that's cheating. If they're out there and they're gaining access to this information and they somehow feel like that they knew that 1066 was the Battle of Hastings after looking it up and they feel smart, well, if they look up the solution to their physics problem and they put it in and they feel like they did that homework, they don't understand why they don't do well on the test. And it's our job to get the recipe right and structure the class in such a way and communicate with them such that that doesn't happen. And I really love this Einstein quote: learning is experience, everything else is just information. This is a really long quote, but I think it's worth it. I don't know if you know who Dan Ariely is. He's a Duke professor. He's given a couple of TED Talks. This is a quote from one of those, and so I'm just going to read it. 1% of people will always be honest and never steal, the locksmith said. Another 1% will always be dishonest and always try to pick your lock and steal your television. And the rest will be honest as long as the conditions are right. But if they're tempted enough, they'll be dishonest too. Locks won't protect you from the thieves who can get into your house if they really want to. They will only protect you from the mostly honest people who might be tempted to try your door if it had no lock. Well, I don't know that when you look at the academic research that it really is 1% will always cheat and 1% won't. This was just a framing of this. But those 98% of the people that are left that will be honest if the conditions are right, we simply need to work to get those conditions right for them, and that's really what we're talking about here. So the spectrum of students and whether or not we can help them. Imagine that we were able to put in place guards, metrics, and communication with the student such that we were able to broadly solve this problem of cheating. Who are the students that are out there? Because they don't all fall into the same profile, and can we help them? Well, here at the top, there's students who don't need to cheat because they're the whiz kid, and therefore they don't cheat. They go and they get their 99 on the homework. Could we help this student? Yes, by allowing them to differentiate themselves. If cheating is so easy that all the students can get access to solutions online, and that's what the majority of the class is doing, and I just want to show of hands a little bit. How many of you know that this is a problem? How many of you know that students are going online to get the solutions, right? Okay, so how many of you have struggled with a grade sheet that winds up with grades that are all in the high 90s on the homework and certainly isn't reflected on the exams? So at least half the room is saying they've had that trouble. Well, the students who are the whiz kids who really can get the 99, they don't get differentiated. They don't get to be up there at the top because they're right there with everyone else. What about the students who don't cheat on principle? Yeah, we can help them as well. They're already not cheating, but they're getting an 82 because they earned it, and they look like the worst student in the class, and that can't feel good. So then there are students who are maybe like the person above who would get the 82 if they worked on it, but they don't quite have the discipline. And they're pulled along and they decide to cheat because everyone else is doing it, or because they don't know that that's something that's wrong. Can we help them? Yeah, we can, by getting a level playing field, by communicating clearly to them that all students understand this shouldn't be done, and now you can do earnest work, and when you make your 78 or 84, you are not going to be one of the only students in the class who didn't get a high 90s. So you can help them. So what about students who will cheat no matter what? Can we help them? No. It's unlikely that you're going to be able to either help or stop them. They're the ones who, at all costs, will find a way to get the answers. They'll take the extra steps. And so all that we can hold comfort in is the fact that they are not the majority of the spectrum. The quote that we looked at earlier said they're the 1%. A lot of the academic research varies on that a little bit, but it's not more than 5% in any research that we were able to find. And then finally, this isn't a student group, but the instructors who want more accurate assessments. Can we help them? Yes, by giving them more accurate assessments. That's something I think that everyone in this room would probably be more interested in, is a broader spectrum of homework grades that correlates better to what the students are doing in the other elements of the class. So this is the spectrum of students. And what have we been doing already, and what are some of the things that are important? You cannot have problems that are in print and expect not to have an issue with cheating. There are answer sharing websites that have made it their business to have the solutions manual for every book that's out there. And if your problems are in print, those can be up there without copyright infringement, because they're not putting a copyrighted block of text up. They're simply saying for any given book, and I don't want to pick on one book, so I won't name an author, but they're saying for this book, for chapter 3, for problem 15, here's the solution, and that solution is authored by a Chegg employee, so nothing about that is copyright infringement, and therefore no one can ask them to take it down. Our problems are not in print. When instructors create assignments, they're doing so through the Expert TA website, and they can see they're assigning problem 3513 and 3517. The students just see that show up as problem 1, problem 2, and problem 3. So there's no way to look up an indexed account of these. Our problems will still make it out there, but students have to take a picture with their cell phone or take a screen capture and upload it to Yahoo Answers or one of these other online answer sharing websites. And at that point, when they're housing our entire problem statement, it is copyrighted information. And what I could do right now is come over here. I'm logged in here to main@theexpertta.com, and you can see here that there's an abundance of emails where I have searched for copyrightagent@chegg.com. This was from a couple of days ago, and this was posted Friday of this week. And it says, "Dear copyright agent, in the past you've promptly removed our copyrighted content when we've made reports. We appreciate your quick consideration." And if I scroll down, you can see that the following day at 4:02 a.m., Mr. Kilburn, "Thank you for bringing this to our attention. The content you reported has been removed." So we instituted a web crawler. Google has a web crawler that looks across the web at absolutely everything indiscriminately and tries to catalog and index it. We have a web crawler that's very specific. It goes into our database, it grabs a problem statement, and it tries to find that out on the web. And when it does, at Yahoo Answers or Chegg, we get a list of these in the form of an Excel spreadsheet. We have all those URLs, we report them, they're taken down, we rerun our web crawler, and sure enough, they are taken down. So use problems that are not in print. When your copyrighted information makes it out there onto the web, police it, and then have them take it down. You need in-system features like random numbers, and the next two I'm going to explain just a little bit about. Random phrases. We're the only system on the market that has this, and it's very similar to random numbers. A random number, there's a placeholder. There's a min, a max, and a step size, and each student's going to get a different number based on that information. With a random phrase, there's a placeholder, and then there is an array or a list of alternate wordings or answers. One student sits down to a problem that says, "A firefighter stands on a fire escape," and it goes on to ask something. So now imagine that that student takes a screen capture and posts it up to Yahoo Answers, and an answer is provided. Any other student who had that exact problem, if they did a Google search, they would likely find that problem. So a way to deter this a little further is randomized phrases. A firefighter on a fire escape is the problem that one student got. The next student gets the same physics problem, but it says an attorney stands on a balcony. It doesn't change the physics, but we change enough of the wording so that the student searching through Google for an attorney on a balcony doesn't get the hit and they don't get that solution. So while the solutions that we have are up there briefly, we make it harder for the other students to find through mechanisms like this. Here's a question, is it working? We have an abundance of users that transitioned over from one of the other major players with a frustration of grade inflation or homework grades that were up in the high 90s. And I have permission to share this. This is one of those. The semester before, they converted to Expert TA, all high 90s. So this is Dr. John Farley at UNLV, and of course this information is anonymized. And so you can see there's some color coding here, where the grades in red are the lowest, the grades in dark blue are the highest, and then there's a gradient and a spectrum in between. And you can see that the grades are quite varied. And then if we scroll down here, for the overall homework average across these, this is what the distribution looks like of A's, B's, C's, and D's. It's not a perfect bell curve, but it's headed in the right direction. It's certainly not all high 90s. This is an indication that it's working, and we see this across almost every instructor who switches to Expert TA. They're very happy with this, and many, many instructors go through the steps in order to take their homework grades and do a formal mathematical correlation between the homework grades and then everything else that happened in the class, excluding the homework grades. And the C students are matching with the C students, and they correlate very well. So we also see through our analytics highly engaged students, that when they're solving the problems, they're accessing hints a lot, they're accessing feedback a lot, and they're taking multiple steps. They're not just going to the internet and getting an answer. So to a large degree, we do see it working. Now the bad news, we don't think it's going to work forever. And the reason that it's not going to work forever is because we're in an arms race with some of these websites. And I guess I can name it because it's so well known. Chegg.com is one of these. It used to be that to post a problem and have it solved was a very expensive account for students. Now they have more manpower for these problems that are submitted to be solved, such that more students can afford to have those, and therefore instead of going on and searching predominantly, a student will simply post their version. They'll take a picture of their problem. They'll post it to Chegg, and 15 to 20 minutes later, they have that solution. And I think this is really important for everyone to understand. We have instructors who say, yeah, I know we've adopted departmentally, but I personally don't use online homework. I use my own questions because the cat's out of the bag. It's too tough wherever. This applies. Chegg.com applies to using your own problems, even if they're in print. Because if you hand out a homework assignment, a student can take a picture of that, submit it to Chegg, and someone's there to solve it. Now, what that means is our web crawler and our reactive approach of having those removed is no longer going to suffice because it's too easy for each student to post his or her own problem up there. So these are the things that we're going to talk about towards the end of the presentation, but these are the things that we have been doing, and as you could see from the grade sheet that we posted, these things have been working, and we are forward thinking. We understand that we can't sit back and be complacent at this point, and for a topic as important as this, where we talked before, we have these great educational tools, and I'm sure that you all build these things yourself. You have these exercises that students are supposed to go through that they're going to benefit from if they do go through that. Well, if they have a shortcut to circumvent that process and get the answer from someone else and just have that put in, they do not benefit from that educational experience. And while we'd like to focus on all the positive stuff, again, if we don't think about this, all of us, then we're going to wind up in a situation where students aren't getting the material for these reasons because they're not really truly utilizing the great things that we built for them to do. Please do.
The distribution of ABCs, Ds, that was at a larger standard deviation because not all students were able to cheat and get the correct answers. So without your system, it would be skewed heavily towards all A's.
That's exactly right. And in fact, the semester before that study that we did with John Farley at UNLV, he was using another online homework system, and he was assigning problems that were from end of chapter questions in the book, and it was heavily skewed. His homework average was 98 point something. Okay, at this point, this is the section where we want to go in, and we do want to show you the system, and we do want to focus primarily on the positive aspects of our student learning tools. Here's our main forward-facing website. A lot of great information out here. If you click log in, you're taken to a login screen, and then I've gone ahead and I've logged in. It's one of the demonstration instructors that we have. Screen resolution is always a challenge when you're doing a presentation like this. It's easier to get a PowerPoint with a very big font to come through. When you're looking at an application like this, you just have to understand that you may not be able to see everything. I'll try and add commentary to help out with that. So some of the things that we think are important in our system are flexibility for the instructor so that they can design how students are going to interact. We do have instructor grade preferences out here, and when you get an account, you only have instructor defaults, but you can add as many templates as you like if you have different types of assignments. If you have warm-up assignments, homework, quizzes, those kind of things. Now, if I click on this, the table to the right, this form, is not going to change in structure. It's only the parameters that are in here. For homework, I have a number of submission attempts allowed of 5. I have a deduction for each of those is 4 points. We have the ability to control whether or not students can access hints and feedback during an assignment, deduction values associated with accessing those pieces of information. Can students have the correct answer? What if they use up all their tries and you have a multi-part problem and they use up all their tries on A and they still haven't gotten a right answer? Do you want to show them what the right answer was so they can build the rest of their solution on a proper foundation? In homework, probably yes. Maybe in a quiz, you might not want to do that. But the point is that it's completely up to you, and you can build more than one template. Late work is a great way to incentivize students to look at the material even if they were not able to complete it prior to the due date. And we have some instructors who make the late work available and have the end date all the way out at the end of the semester, so that even when students are studying for the final, if they didn't do a few questions, it still makes sense for them to do those. You have randomization of variables and phrases, and you can turn those on and off. Most instructors like to leave those on, but it's your choice. And then partial credit. Partial credit for the final answer is something that I want you to remember right now. So a student has 5 tries on a question, and they've used up 4 of those. On their 5th attempt, they still don't put in the exact right answer. They have a plus versus a minus. They have a trig error. Do you want to give them a 0? Or if we recognize that it's close, do you want to give them some credit for that? And so this is what we call true partial credit grading, and we are the only system that offers this feature. So without staying here for too long, I'll just click on warm-up assignment to give you an idea that if you're just wanting students to look at material before a lecture, you might give them a lot of tries and take off no deductions for accessing hints, feedback, or putting in wrong answers. The customization is there. Unless there's any questions, I'd like to move forward so that we can look at some of the other features.
Sorry, I got here 5 minutes late, but the questions, can they be from textbooks that were used, let's say, in class?
We have an independent library of questions that service Physics 1, Physics 2, and Modern for the last part of it. These have been used for 6 years, and they've been used at large enrollment universities, departmental adoption at Auburn starting in fall of 13. Never looked back. They're very satisfied. Princeton University adopted in fall 14 departmentally, never looked back. We have a lot of schools that tell us that the content that we have is certainly abundant, and the features that we have to service those courses. The only other content that we have is we partner with OpenStax, and we have every question from college physics in, and we've also enhanced those questions as we've put them in, and we are currently coding in all of the university physics questions as well. And you as a general user of ExpertTA have access to all of those, no matter what your setup is. And so that is 3,500 questions, really growing to probably 4,000 here shortly. Any other questions before we leave customizable assignments and grade preferences? All of these templates that you've got here, homework, quiz, default, those are going to be conveniently available when you go to create an assignment anytime in the future. So you really just want to set those up once, and then they'll be available. So let's do that now. We have a homework 1 and 2 and 3 and a quiz 1. We can come over here and say create class assignment. And this is one screen that allows you to do everything. And we've heard from instructors that they feel like we got this right, that it's user-friendly. Let's type in here homework 4. And I think I misspelled that, but that's okay. Let's just say that we're going to assign some force problems. And so you can control the weight of the assignment. You have the templates that we just talked about. Any that you've created are available for you to select. I'm going to make this a homework assignment. You have drop-downs that are calendars that allow you to set the start, the due, and the end date. Any work done between the start and the due date, students are going to earn full credit for. Any work done between the due date and the end date, that's where your late work percentage applies. And so by default, late work isn't allowed. You would have to come in here and extend this out to offer an extra few days for students to do late work. And of course, as I said, some instructors choose to set that all the way to the end of the semester so that they can work on it at any time. Now, down below here, we have the interface that allows you to select problems to put into this assignment. There's a drop-down that allows you to get to the chapter. I'm just going to choose Newton's laws. If I knew a specific section, I could hit the plus button and expand that, but I'm just going to choose to say expand all, and we can scroll through here, and you'll be able to see that the layout we designed was really intended to feel like you had opened a book to the end of the chapter so that you can see problems in that same way. You see the problem statement, you see the individual parts that the students are going to be asked to solve for. So this is a 4-part problem. Well, let's just go ahead and add this. And unfortunately, with screen resolution, you have to scroll a little bit, but you can see now up here that that problem is added into the list as problem number 1. And so we'll just click to add a few additional questions here. And since academic integrity is important related to this presentation, I want to show you question pools. So now I have 3 questions that are here. As I add new problems, they're just added to the list as a new problem number. But question pools means that I could come in here to this 5312, and you may notice that we have an alternate version of 5312. This is true of a lot of the problems in our system where there's a slight variation on that. Now, what you could do here is click on the radio button to the left of problem 2 and watch what happens when I add 5312 alternate. It's added off to the side of this. When students start the assignment, they are going to be randomly assigned one of those 2 questions. And every time they come back, of course, that will be the version that they get. It's just like random numbers. And there's nothing stopping, by the way, you from adding 3 questions or 4 into a question pool. So this means that you're able to set up an assignment where problem 1 is 3 or 4 similar questions asking a similar topic, and each student's going to get a different one of those. I'm sure you're all capable of doing permutation calculations. You could see that really quickly the number of different assignment configurations is more than the number of students in the class, and no students are really going to get the same exact assignment, and therefore over collaboration doesn't become an issue. The 2 students who get different versions of 5312, it would benefit them. They can collaborate and talk about the concepts, but not just directly share answers, and that's the kind of collaboration that you want. A few other things about this portion of the interface, and then we're going to move on. We make it really easy for you to find what you're looking for. There's filters here for problem difficulty. There's filters here for problem type, algebra, conceptual questions. And what we mean by calculus is, does it explicitly involve a derivative, an integral, some sort of calculus operation? Because as you know, if you've ever taught a calculus-based physics class, a lot of the problems would be just perfectly fine in an algebra-based class. So that's what this filter is. And we also append this information onto the end of the problem so that at a glance you can see that this does not involve calculus. This is an algebra-based problem, and its difficulty level is 4. This is the way that you're able to shop for problems. This is the way that you're able to create assignments. It is considered by most of our users to be very intuitive. What do you think? Does anyone have any comments? Does, just overall consensus, does this look like it's relatively easy to use? Okay, I see some nods. Great. Unless there's any other questions, I want to make a few wrap-up comments. We do have a truncated demonstration to accommodate for the front and back academic integrity. So we can't show every feature, but we have a full suite of class management tools. If you want to have a timed assignment, you can see that it's there. You have the ability to do that. If you have students who need extensions, you have the ability to pick out a student and give them a few extra days, have the assignment start later. There's complete flexibility for those kinds of things. And so anything that you do that you need to do to manage your class, you're going to be able to, but we're not going to be able to show them all today. So please feel free to ask us those questions later. For what I want to do right now, I'd like to save this, exit, and I want to log in as a student so that we can show what the interface would look like from a student perspective. I'm now in as instructor 2, student 2. The interface here is very similar, and I guess I can talk about the layout of this page for just a moment. You have a list of your assignments, the weights, the start, the due, and the end date. If an assignment is timed, you can see the number of minutes that are allowed. And then the only column that's added here in the student view is the status. Have you completed the assignment? Have you partially completed it? Have you done no work at all? The menus are going to be much more limited. Student can only take an assignment, view a printable version of that, and maybe look at grade reports or grades associated with their assignments. They can't create assignments. So what we'll do right now is, I think, just jump right into taking an assignment. Here's your interface. It's relatively basic and intuitive. Off to the left, you have some navigation that allows you to click between problem 1, problem 2, and problem 3. And simply navigate through your assignment. On any given problem, you're going to have the problem statement, the image, if there is one, presented to the right, and below there's an interface for the students to complete each part of the problem. I don't think that we're going to have time to talk about this today. Historically, what we've done for free body diagrams, schematic circuits, and things like that is multiple choice between images, where there's one correct free body diagram and 5 variations on that with forces that are moved or misplaced. But we are releasing this fall semester an interface, a problem type that lets students draw their own free body diagrams, and it's very user-friendly. It doesn't rely on Flash, so it's cross-browser compatible for the iPhone, for the iPad, and the grading behind it allows for feedback and for partial credit. If you're missing a force, if you have a force in the wrong direction, it's able to give you meaningful feedback about what's wrong with your free body diagram. We've been beta testing it, and it has very positive initial reviews. We're told that we've got it right. For this demonstration, we're just going to look at the existing style that's in production. So some of the things that are important to students: transparency of grading. Instructors are able to go and specify all sorts of grade preferences, but in some other systems, that doesn't come through all that clearly to the students. And so you'll notice here, the student knows that they're starting off with 100 potential. They have 5 tries remaining on this multiple choice question. They'll lose 20% for each incorrect answer. There are hints available, and they would cost the student 2% each. And so now I could go and access those, and you can see that the grade up here under potential has automatically updated. So students really appreciate the transparency of grading. And then since this is just multiple choice, we're not going to spend a lot of time here, but I do want to show you that each one of these incorrect answers has specific feedback to that mistake. So right here, for example, the angle is measured from bottom vertical rather than horizontal. And so the feedback associated with this is going to say, be careful with your geometry, look closely at the provided image and how things are labeled. Versus if they had chosen this incorrect answer, where the normal force has been neglected, the feedback says, you're missing at least one force if you considered all the forces that would be imparted on the body by interacting with other objects. In this case, that happens to be the surface. So the feedback is specific to the mistakes made, and the position of these images is randomly assigned. So the right answer happens to be in the bottom right for this student. That wouldn't be the case for any other student. All of these would be jumbled up. So let's click submit, and we got it correct. And there's this little summary that shows up. What was the correct answer, what the student put in, and then what's the submission history. Now, what's worth commenting on here is that all of this information is being built up into a grade report that both the instructor and the student will be able to access at any time in the future. So you as the instructor will get a grade sheet that has all the numeric values, and that's very convenient. But if a student emails you and says they're not sure what they did wrong on a particular problem or part, you'll be able to go in and see their detailed work, all of the information that they put in for that. And of course, students can use this in order to study and look back at their work as well. This is really the feature that separates expert TA the most. It's the ability for us to handle symbolic expressions and to do so in a sophisticated manner. And there's a couple of things that I feel the need to comment on here. There's an entire chapter in my PhD dissertation about how do you get scientific equations in for the purposes of online homework, and what are the ways in which you could stub your toe. And some of those things are done by other systems. One of those things is if you leave this entry area completely open to where you can type in anything, that causes a lot of problems, but the easiest one to describe is variable confusion. The correct answer is x plus 3. The student puts in capital X plus 3. They clearly understand the concept that's going on, but the X versus capital X means the system doesn't recognize the answer. You get a red X, you get no feedback, you're told you're doing something wrong, and that's the worst case that you can be in, where you really understand the concept, but the system's just not accepting it because of some syntax. Well, we don't have that. We have a prescribed nomenclature here that contains all of the variables that are needed, plus some distractor variables that the students have to look past. There is one other mistake that I think most of the other systems make, and that's the fact that they make these complex drill down palettes that have all of the trig symbols in one sub area, and then all of the, so you've got Greek symbols and you've got trig functions, and so you can get your equation in, but it feels a lot like using Microsoft's equation editor. It's not always obvious, and there's a lot of extra clicking, and sometimes students know the equation they want to put in, but they may not be able to get it in without asking a question to someone. And so everything that you need is right here. It's on the screen. To the right here, numbers, operators, and some navigation. That's going to be consistent basically with any problem that you go to. this prescribed nomenclature in this collection of variables, that's going to change from one problem to the next, sometimes one part to the next. So at this point, let's use this to put in an answer, and let's make it something that is two things: not correct so that we can see feedback, and then also not completely mathematically simplified. It looks like the correct answer here would be f2 cosine theta minus f1, given the coordinate system that's specified. So I can come in here and click f2, and I'm going to put in an extra couple of parentheses. Instead of cosine, I'm going to put sine theta. I'm going to put in a +1. That's an extra term that we don't need. It should be minus f1, but let's make it plus f1 like this. Now, we all would look at that and identify there's a trig error, there's a sign error, and there's this extra f2 that's really not needed. When we click submit, it lets the student know it's not right, specific feedback is available, and if we click that feedback, I want to read this because I'm not sure it's readable by the folks in the back. Please look at the angle specified and think about how that affects the trig factors associated with each term. Please look at the specified coordinate system, think about how that affects the sign of each term, and it appears that you have extra terms in your equation that aren't necessary. Does this seem reasonable? Does this seem about what you might tell students in an office hour, aside from maybe simplify a little bit? But it's targeted to the mistakes that are made. And again, I see a couple of heads nodding. This is targeted feedback. A student that types in a different wrong answer, f2 minus f1. Quite commonly, students just forget to include trig altogether. Now the feedback says, you're being asked specifically about what's happening in the x direction. You need to break down each force vector into its x and y components. For this part, you'll only be considering things that are in the x. It's very different feedback. What are some of the other things that students might do? There's two forces, there's an angle. How about f1 cosine theta minus f2, where they just swap f1 and f2? It appears that you've confused two of the key variables in this relationship. Look closely at the provided figure. So what if they do something really off the beaten path? M, G, T, theta. The provided answer is not correct, and no specific feedback is available. The feedback button is disabled, so there's no chance they accidentally click it and take another deduction. They're directed to access the hints, which might help if they're that far off to frame the problem. But there are times when certainly you just can't provide any feedback. And so now, as a last equation that I'm going to type in, I'm going to type in something that's still not right, that would require a tremendous amount of math simplification just to demonstrate the robustness of our math engine and to show you the partial credit aspect we talked about before. Right now, I'm working out of a 78. If we had chosen not to allow partial credit, a wrong answer, even if it's close, would result in a 0. I have the partial credit feature set up, and so we're not going to go down to a 0. So let's do this, and this is going to be a little absurd, but it's just, again, to demonstrate the robustness of the math system. Let's do f2, and the only mistake I'm going to make is sine theta. I'm going to put an m in that I'm going to cancel out later. I'm going to put d divided by d, which is just 1, which doesn't change that. It should be minus f1. It should be minus f1, and I'm also going to put in that m. And anything raised to the 0 power is just 1. So that shouldn't affect that. And now I'm going to divide here by m. And anyone in the room could look at this and say, d over d cancels. Alpha to the beta minus beta is just 1. The m in the denominator is going to cancel. And this is just f2 sine theta minus f1. And when I submit here, notice that I didn't go to a 0. I went to a 58. And let's talk about what happened. The correct answer is f2 cosine theta minus f1. This is what the student put in. This is the simplification that our math engine did and identified as the answer. We let them know that they had a trig error, and for that one answer, if they had only had one attempt, that's B-level work. That's representative of an 80. The 80 then has the other deductions that they accrued along the way, but the point is that they're not taken down to a 0. It's worth commenting about this feedback, where it comes from, and why it's not just this one problem that we're demonstrating here that has good feedback. We have a collection of 3,500 questions. I mentioned that earlier. used at hundreds of universities. And as they make assignments, a lot of these same problems, just like this one that we're looking at here, make it into assignments for many different instructors. As students are doing work, they're doing things just like we're doing here. They're not always getting the right answer on the first try. So 6 years ago, we really had our foray into big data. And we said, why not data mine this? Why not pull out of our databases every wrong answer ever submitted for part B of this problem, and you get 50,000 wrong answers. You then run it through a mathematical process that identifies all the mathematically equivalent ones. A plus B is the same as A minus negative B. And so you really don't want to count those as two different wrong answers. It's one that happened twice. So after you identify all the mathematical equivalent ones, you sort it, and you then have the number one most common incorrect answer submitted by 1,800 students, and you have a second most common. We take the 10 to 20 most common wrong answers, we put those in front of college level instructors who contract author with us. We explain the nature of the Socratic style of feedback that we want, and now our feedback is not limited to just catching math errors, trig errors. You really get feedback about the physics concepts because it's a physics expert looking at this and saying, if a student came into my office hours, what would I tell them? Well, that's what they're writing in there. That goes back into our system, and then the next time a student in the future makes that same mistake, they're going to be presented with that human written feedback. And the way that I always think about it is, if you want to know what a student might do wrong on a problem, look at what 20,000 students already did wrong on that same problem, and you probably have a pretty good idea. So why not plan for that? Now, this has been one of the central missions of our company, and this has been a 5-year data mining process. We do this at the end of every semester, and we continually add to that knowledge base of most common anticipated mistakes. And based on that, we don't have time to look into it today, but we have run analytics report to see the impact of this, and the impact is tremendous. We see students reaching a successful outcome much more often when they access this feedback. And at the beginning, I said I'd much rather not talk about academic integrity. This is the kind of thing I'd rather talk about, building great tools that help students learn and help educators get a good assessment. But if you don't have those protections in place, and students aren't really using these hints and feedback because they can get the answers easily somewhere else, then these tools don't have the value that they really need. Are there any comments from anyone in the audience? Yes? Yes, and the way that I'll be able to show it here, I will pull it up. So let's close down that. Let's go into presentation material. This was a feedback analysis report that was run the first semester that Princeton adopted. And so this was in a large enrollment section of about 300. And the easiest way for us to deliver this right now is offline. We are migrating smaller pieces of this online, but to be able to get the most in-depth look at it, we provide an Excel spreadsheet to you. We can do this periodically throughout the semester, or certainly at the end of the semester. And a lot of instructors use that, looking at the end of the semester, to determine if they need to change their approach the next time they offer the class. But in here, you get these things like feedback sorted and counted. You get to see the most common feedbacks. Let me see if I can find the one that's the group by feedback, group by assignment. Did you see a grouped by assignment? Here it is. So here's a great example. On assignment 1A at Princeton, out of 300 students in the class, 109 students made the mistake that led to the feedback: the diver jumps from the edge of the board, not the edge of the pool. You forgot to include the length of the diving board. And so you get to see all of these most common mistakes for your class. And that certainly is something that could help you to then go back and reframe how you offer something in the future. Now, I will point out one last thing, and then we're going to be out of time on this and have to close on the academic integrity. The feedback that you're looking at right there is way too direct, in my opinion. And that feedback no longer exists written in that form. You're telling the student too much. The diver jumps from the edge of the board, not the edge of the pool. So not only do instructors look at this, we look at the feedback that is being provided and has been authored. Our authors do a good job, but you know, when you get a lot of contributors, not everyone's going to hit the nail right on the head the first time. And so we felt like this was too direct, and this was rewritten at some point to be more Socratic since fall 14. And so this helps us internally as well to improve our product continually. So it's informative for the instructor, and it's also helping us to refine and make a better product. We are going to have to shift back out of this. And again, I warned that we would not be able to see every feature. I am going to show one thing here by logging back in as the instructor. I'm going to go into this homework 4, and I'm going to look at the view grades spreadsheet. And you're only going to see one grade right now, this instructor 2, student 2. But I did want to show you that not only do you have access to that grade that's going on, the progress that's being made on it, but if you click on that numeric grade in as the instructor, you now can see the detailed work for this student, and not just a final submission. You can see every submission that was made. And this is very helpful, again, if a student has a question where they don't understand what they're doing wrong. There are certainly other system features, and let's come back over here and let's talk about those without looking at them in detail. What are some of the key remaining features and frequently asked questions? Our price is $32.50 for a semester. It's capped out at $65 to get students through the introductory sequence, no matter how long that takes. So if a student has to retake Physics 1 or Physics 2 or both, means they might be in introductory physics for 4 semesters, they're still only going to be charged for 2 of those semesters. We have a commitment to get them through at $65. For high school, it's $15 for the academic year. Our grades are easily exportable and formatted to be easily uploaded into LMS systems. And I can also tell you that LMS integration is something that's coming for the spring of 2018. We've been working on that for some time, and we're already testing scenarios, integrating in with Canvas and all the other LMS systems. So pretty soon, you won't have to export and import grades. Those will just sync over directly. Textbook mapping. We have our independent collection of questions. We also have OpenStax. When you go to use those, we're going to have projectile motion questions just like any of those books, and they're going to be perfectly sufficient, just like they are for some of these prestigious schools we named. To make it easy for you to find those problems, we have mapped them to all the most popular textbooks. So when you're using Knight or Halliday-Resnick, projectile motion may show up in a different chapter section, but that's okay. We flip a switch in the background, and since we've mapped all of this, when you go to create an assignment in Expert TA, you go over to the same chapter and the same section that topic is covered in Young and Friedman, and there's all the problems associated with that topic. We are strong partners with OpenStax. I already mentioned that, so I'm going to move past this. The content and features have been used successfully at some big name schools, and hopefully that bolsters your confidence in the ability for this to work for you. And this is not just at the big names, by the way. Remedial high schools, community colleges, across the spectrum, we have the level of difficulty and the appropriate content. If we didn't answer any question, please do contact us, let us know. Now, we've got to get back in here, and now what I'm looking at is the last 11 minutes instead of the last 15. If I go over a couple of minutes, hopefully that'll be okay. But the spectrum of students we talked about earlier, the only thing to mention here is that most of these students we can have some sort of an impact on. That is what the research that we have looked at says across the board at multiple institutions, multiple disciplines. They say the students at the bottom who will always cheat does not represent a majority of who you are looking at. We identify that cheating is due to the internet, and most of that is perceptions, students not understanding. Right here, there's a study out of the University of Nebraska, and there's a quote from this. Just 23% of students who were polled as part of this major study said that doing individual homework with a partner was dishonest. 91% had done so. They did not think that that was dishonest. And I can offer a quick anecdote from a professor who told us a story just as they were changing to Expert TA. They were holding office hours in the computer lab so that as students were doing their online homework with the other system they were using before us, could ask questions during that. A hand goes up. The instructor walks over, and the student says, I'm having trouble. It's actually 2 students, and they say, we're having trouble with problem number 3. We were able to get problem 1 and 2 because we were able to find the solution on Chegg and then put that in, but this problem number 3 is not on Chegg, and so we're having more trouble. And the instructor says, do you realize that you're not supposed to be doing that, that's cheating. And they were mortified. And they said, no, we had no idea that we weren't supposed to be using this resource. They were a little embarrassed, and they never did it again. But it was the simple fact that it was not just a perception problem. It was a failure of communication for the instructor. He did not have anything on his syllabus, which he now does, that identified here is clearly what resources you can use during online homework. If you've ever given a take-home test, you know that you can say it's closed book, and they have an honor code, and they're supposed to stick to that. How many of you put on your syllabus during homework, here are the resources that are not available? This is identified as academic dishonesty. If you're not doing that, then right there, step number one is something that you can be doing, because these studies show that students just don't know that this is the case. Now I have pulled up over here, there's the quote from that, but this was pulled from this right here. University of Nebraska-Lincoln, most high schoolers cheat, but don't always see it as cheating, study finds. I'd be happy, anyone who's interested, I'll give you the full list of references that are included here today and the links over to the full articles, but we're just mainly going to pull quotes from them with the limited time that we have. So this is one of the biggest things that can be done. Let's go back over here and move on to the next one. Donald McCabe, he spent his entire career looking at this problem of cheating. He found that honored codes had tremendous impact. Results suggest that modified honor codes are associated with lower levels of student dishonesty, and that the McCabe and Trevino models appear to be reasonably robust at having major impacts. We're not going to show that because we show something by this McCabe group. He made the cut twice here from his research. We had the big quote earlier from Dan Ariely. Let's talk about the experiments, the number of experiments that have been done that prove these honor codes work. You can pick, you can listen to this. He's got a great TED talk about this. There's an experiment where students go into a room, there's a set of dice, they're not monitored at all. They roll the dice, they look at a sheet off to the side that specifies the winning rolls, and they come out and they self-report and say, did you win or not? And the prize is $2. Now they can go buy a cup of coffee, for doing this. If they didn't win, they get nothing. Magically, 7 out of 10 students come out and they're reporting winning, even though the mathematics associated with the probability of those rolls is 40%. You do it on enough students and you know that they're over-reporting. So all they do is this. They add in that before they go in and they make the roll and they come out and they report back, there is the MIT student honor code that they have to sign. And he laughs when he tells about this in the TED Talk. There is no MIT student honor code. But just the presence of that had students coming out and reporting 4 out of 10 winning, so they're back to being honest. Dave Pritchard, MIT professor, creative mastering physics. I should, for full disclosure, note that he is now a collaborator, a friend. He's sitting here in the second row. We can go over here and look at a quote here. We could look at it in this context, but I'd like to go over it and look at it in the blog that David and I wrote, which was, or co-authored together here, which is students don't want to cheat, and teachers can help them stay clean. And we included a lot of this, the research that he had done at MIT based on this. And if we could come down here and we could find this, changes in course format and instructional practices were accompanied by a more than a factor of 4 reduction of copying, as expected, since repetitive copiers have approximately 3 times the chance of failing. This was accompanied by a reduction in the overall course failure rate. The point is that there are things that can be done. Now, here's the last one, which I think is the most comprehensive and why I didn't have something to look away here for the McCabe up here. A decade of research suggests that mechanisms like honor code, clear communication could dramatically reduce cheating. Harsh penalties were one of the other component. And I do want to come over here and I do want to show you this, a decade of research. And you can see McCabe here from Rutgers University, Penn State University, and Washington State were also involved in this. Here's the table towards the bottom that I pulled out that I want to focus on. And you can see it's under the category of suggestions for preventing cheating in academic institutions. And if we scroll down here, this is the table of interest, managing cheating based on the student perspective. I'm going to move out now and move back in here so that we can look at a color-coded version of this. They're not in the same order here, but the yellow, establish an honor code. That's suggestion number 3. Consider establishing a classroom honor code. We've already talked about this with the Ariely experiment, that the studies show that these things do have an impact. And the perception of a lot of instructors is that doesn't do any good because students are just going to cheat anyway. That's not what the research shows. 2, clearly communicate with your students. And that's items 1 and 2. Establish and communicate cheating policies and encourage students to abide by them. Clearly communicate expectations. Not all instructors are taking that step, which is why the professor from my anecdote earlier, who told me this in the phone conversation, had a student coming over there and clearly wasn't even trying to conceal that they were using Chegg. They told the instructor that. They clearly did not understand what was and wasn't allowed. Looking down further, remove opportunities for cheating, and they give suggestions which you might not be able to read at the back of the room. Monitor tests. Be sure there's ample space between test takers. And then the last one is deter cheating with harsh policies. Now, why have I highlighted these and not the rest of them? Because these are the only things that we can really consider as we're building in Expert TA. The rest of these are great advice, but they're really more associated with instructor. So be supportive when dealing with students. Instructors probably should do that, but that's not going to affect our technology. So these 4 things are taken away from the literature, our review of the literature, and they're all stated to have high impacts. Now let's go and look at what Expert TA is doing in the new era where students can take a picture of a problem, an Expert TA problem, and I guess I do want to show this in here. Does this look familiar? This is the problem we were looking at earlier. That's a screen capture. This is up on Chegg.com. There's the Expert TA copyright. It's right there, and if I click next, you can see the bottom part of the problem. This is just a screen capture that was taken in 2 stages, and you can see the solution down here, F2 cosine theta minus F1. It's posted up there. We've disabled in Expert TA the ability to copy and paste, but now everyone takes their phone out. They take a picture. They use the Chegg app. They upload it. We're in a new world. We're in a new landscape, and so we've got to have deterrence against that. With those things in mind right here, the honor code, clear communication, remove opportunities, and then harsh penalties, let's talk about how we're implementing those. Establish an honor code. Well, we've got a template that you can use if you don't already have one. You can tweak the language. You can paste right in the school's honor code. That's going to be within the Expert TA system, and you're going to be recommended to put that on your syllabus. But then the clear communication, we have a new page that pops up every time a student goes to take an assignment. And it has the class policies, it has the honor code, and something that's not mentioned here, it has our increased, much more aggressive terms of service. Our terms of service, which now are a little more in the face of the student, are a threat that identify taking our copywritten material and posting this up, like what you just saw from the screen capture onto Chegg, is a violation of the use of Expert TA. And if it is determined that you have done this, you can lose access to your Expert TA account, and you would have to make alternate arrangements with your instructor in order to do homework for the rest of the semester. Are we going to do that, especially without the instructor buy-in? Probably not. That would be a case-by-case where the instructor would let us know how we wanted to do that. We're not going to make it our business to just left and right remove students from the class. So now, every time a student opens up an assignment, before they can go in and work, they're presented with the honor code, the class policies, the fact that they're not supposed to be using online resources like Chegg, and a reminder of these terms of services. They're reminded each time. All right, now inside of the system, very briefly, question pools, random numbers, phrases, those are things we're already doing. The new things that we're going to do to make it harder, and this falls into the remove cheating opportunities, is now the students clearly know what they're not supposed to be doing. They can't copy and paste our problem statements. I guess they could retype them. So the quick and dirty way they do it is they take the picture with their cell phone. So we are now putting personally identifiable information within their problem statement. And that doesn't violate their privacy, because if they're not breaking any rules, when they're logged in the upper right of the Expert TA system, they already see, if I page up here, you already see your username right there. So you're the only person that's going to see that unless you choose to post it somewhere. And so we are going to put personally identifiable information, the student name, and then we also have a tracking ID that's specific to that student, to that problem. And now, if they take a picture and they load it up to Chegg, there's a way to find out exactly which student did that. And furthermore, there's ways for us to automatically find out who those people are. When the image is uploaded and it's put up there of the problem, they have an OCR that transcribes all this stuff, including our little copyright, including our tracking ID, and including the student name there. All of that stuff, when our web crawler runs in the future, will be able to be pulled back in automatically. When that's done, we'll be able to create a blacklist of students who have violated these policies. And then the final real deterrent is inside of the Expert TA system. Imagine on homework 1, the student had taken a picture and posted up several problems, and their identifiable information was in there. The OCR catches it, our automation pulls it back in. As they're taking assignment number 2, a warning can pop up and say to the students, we know that you posted several problems out, and we're able to detect that, and you really should not, you should consider not doing that, because here's a reminder of the fact that you could lose your Expert TA account. This message has been sent to your instructor. We're doing all of this with instructor flexibility, and I think we need to go over and look at that, and then I can work to wrap this up. You saw earlier the grade preferences where you can customize the number of attempts. You'll have a new page in here, and this is, let me see if I can zoom in on this. I don't see a tool that's obvious, and with the mouse, there we go. Okay, that's better, if I can get it to scroll up here. So now you'll be able to create these different academic integrity templates in case you want to do some things on one assignment and some on the other. But we'll have a recommendation to post something on your syllabus, as we said earlier. Communicate with your students. You'll have the ability to turn off, if you don't want it, the academic integrity honor code policy page that pops up before every assignment. And you get to determine whether you want to show our terms of service, so one, the other, both. You can customize the language for your honor code, but we do have template material in there. The in-class deterrence, display the student name in the problem area, display the tracking ID in the problem area. If you wanted to not have this, you certainly can turn all of this off. And student violation notifications. Do you want us to police this and find out when individual students have broken these rules and put this material up on Yahoo Answers or other answer sharing websites like Chegg? And if so, do you want us to provide alerts to the student? Do you want to get alerts on this? One or the other or both? Now, let's go to the next one over here. And so I'll have to zoom out, and then let's see if I can click over. This is just right now the look, and not everything's coming through here because of some of these headers, but here's the page that would be presented to the student right before they go to take an exam or take an assignment. They're presented with this page before they're actually taken in there. And again, it can have the honor code, the terms of service, where they could lose access to their account, and by clicking continue, you agree and understand these. And then finally, here gives you an idea, and let's zoom in just a little bit. Now we have the student information in gray appended to the end of the problem statement. You have this Expert TA copyright, tracking ID, and we've got a little bit of language that says, in accordance with Expert TA's terms of service, you're not supposed to post this out anywhere. Don't violate our copyrights. And so now if someone wanted to post this up, and they were really the 1% of students who are always going to cheat, they can put this into Photoshop, they can black it out, they can still post it up there. It's an extra step that they have to take, and so you certainly are putting more barriers. Right now, it's just so easy that there's no locks on the doors, going back to the locksmith analogy, that it's so easy for students to do this that they just do it, and they don't even think about it as cheating. Now you're telling them, you're reiterating, you're letting them know this is not allowed, and you're putting this information in here that it would have to be a very overt action of cheating now to black this information out and to post it up there. One final comment, even if they black it out, they're still not safe. Why is that? Look at the 4 random numbers that are here. Each of these random numbers have a range between, the mass is between 10 and 20 with a step size of 0.1. All of these have a range of 10 with a step size of 0.1. That's a million different combinations of values, way over the number of students. And we have the code to give one student one specific range of values. So even if you were to black out all this stuff, if you post it up to Chegg, based on the numbers here, we can go back and figure out the one student who had that combination of numbers. So they're not even safe there. And word will spread when students start getting alerts that are also sent to the instructor that they're posting their problems up. Fewer students are going to be going and doing things like that. So now let's just close out here to say that our passion is still about building tools that are really to help students learn. But again, if you don't protect this and you don't have mechanisms in place to keep students from circumventing that, they don't really do these great exercises, these educational experiences we want them to go through. And it's really damaging to them and they don't realize it. So we have to be the guardians who help to keep them on track, and we have to just put some locks on the door, and that's what we've tried to do. And after this is done, we will still try to be forward-looking. I don't know who else is doing the things that we're doing, but we will still try to be forward-looking because it's important. But at least for right now, we're going to consider this pretty good for the near future, and we're going to get back to building more free body diagram drawing packages and looking at other ways that we can really help the students learn. I welcome any questions now, and please, we would welcome any feedback via the surveys that have circulated here. Anything that you can tell us about what we're doing, how we could improve, or if we're on the right track, that'd be very helpful. Thanks again for coming today.